Hey, welcome back, my little butter biscuits. We are going to talk about graphing inequalities today. So, I know what you're thinking. Barton, I can't even graph regular stuff. Oh well, c'est la vie. Here we go. We're going to graph inequalities. So, it's actually not too bad. Pardon me. For your graphing inequalities, you, on your homework, I've already looked at it, you're going to have some pretty easy graphs. I think two of them are going to be either a vertical line or a horizontal line, right? And then the last one is going to be a diagonal, and they're going to make a triangle, right? You are going to have to figure out where the solutions are, because this breaks up your graph into a bunch of different sections, right? They could be up here, they could be in this section, they could be down there somewhere. So you're going to have to graph the three inequalities, and then you have to figure out what part of the graph are the solutions in. So let's go learn how to graph one inequality first, and then we'll learn how to graph a system of inequalities, and then we'll learn how to figure out where pardon me, let me get a sip of water. Then we'll learn how to figure out where the solutions actually are. So let's start with a nice easy one. We have y is less than, let's write these down. This symbol is less than, and I bet you can guess what that means. That's greater than. But you just want to remember that this thing is a crocodile mouth. I don't know if your third grade teacher ever taught you this, but if you have 3 and 4, 3 is less than 4, right? The crocodile mouth always wants to try and eat the bigger thing, right? Because crocodiles are real greedy. There you go. That's ugly. Anyway, so what you really need to know is whichever way it's facing, that's the bigger thing. So this side is bigger than that side. That's what you need to know. The names of them is important, but not the end of the world. You can figure out without them. But there they are just in case. So we have y is less than 2x minus 4. The first thing we want to do to graph this inequality is pretend that this is not one of these mystifying inequality symbols. Let's just pretend it's an equals for now. So we're going to graph y equals 2x minus 4. So this is your y-intercept. That's your b value, right? So we need to go to negative 4 on the y-axis and then put a dot. So 1, 2, 3, 4. Our graph is going to start right there. Now this number next to the x, this is your slope. And what this is saying is rise to, and then run. There's no number on the bottom, so you turn it into a fraction by putting it over 1. So run 1. So we're going to go up 2 over 1. Up 2 over 1. Up 2 over 1. And repeat that. So our graph is going to look something kind of like that. Okay. So this is what y equals 2x minus 4 looks like. We've got our y-intercept, we've got our slope, and we're good to go. Now we need to turn it into an inequality. So the first thing we need to do is if you have a less than or a greater than opposed to a less than or equal to or a greater than or equal to, if you have one without the line under it, your line needs to turn into a dashed line. So let's go make this a dashed line. Okay, that's step 1. Okay, so now we got our nice dashed line because of the less than symbol. Now, what we need to do is figure out where are the solutions. You're going to say, what do you mean, where are the solutions? So, for inequalities, all the points on one side of this line will work. What? So let's just let's pick a test point. Okay, let's pick 0, 0. That's a nice, easy test point. And this is going to tell us which side of the line our solutions are on. If this one works, we know all the solutions are going to be over here. If it doesn't work, they're going to be down here. So what we're going to do is we're going to plug our test point, 0, 0, into the inequality and check and see if it's true or not. So we have 0, because the y is 0, is less than 2 times 0 minus 4. All right, now you simplify. 0 is less than, 2 times 0 is 0, so that goes away, negative 4. Okay, never mind. Less than means more negative. Is it true that 0 is more negative than negative 4? No, absolutely not. This is a false statement. That's not true. 0 is bigger than negative 4. I'd rather have no money than owe someone $4. Make sense? So this test point fails the test, so to say, right? So that tells us this did not work. It's not a solution. So all of our solutions are going to be down here below this graph. So if you pick any ordered pair on this side of the line, it will work. Let's just pick one to check. And you don't want to pick something like out here, right? Like if you pick this point, bro, why are you trying so hard? What does your mom not hug you enough that you decide to pick 4, negative 3 as a test point? Don't do that to yourself. Pick a nice, easy one. How about 3, 0? Let's go test that. So we're going to plug that in. This is 3, 0, just for those at home that can't do oral learning or auditory learning, so to speak. So let's plug in 3, 0. Y is 0, less than 2 times 3. 3 comes from the x that we just picked, minus 4. And for those of you saying, Barton, where did we get 3, 0? It's just any random point that's easy to plug in on this side of our line. So 0 is less than 2 times 3 is 6. 6 minus 4 is 2. Is it true that 0 is smaller than 2? Is this crocodile eating the correct thing to eat the biggest meal possible? Absolutely. That one's true. So that means that this works. If we had chosen this test point, we go, oh, it works, we shade that side of the line. So that's the gist of it. You want to pretend it's an equals, graph the line. Then you pick a test point. If the test point works, you shade that side. If it doesn't work, like when we got 0, 0, you shade the other side. Okay, simple enough. All right, so let's go try a system of these things. They're pretty fun. So don't worry, if you don't get this one, I've got 2 systems just to really like hammer home the point, but we'll get there. So let's start with this one. I picked this one because it's got some weird ones that I want to talk about just to make sure you know what you're talking about. So it says x is less than 2. The first thing we're going to do is pretend this thing is equals. X equals 2. Anytime you have x equals a number, this thing is going to be a vertical line. And I find that a lot of people find this to be a little backwards. They think of this as being a backwards thing to say. They're like, no, that doesn't make sense. That seems reversed from what I think it should be. And you're kind of right. The way I think about it is if x equals a number, then it has to go through the x-axis. That's the way I think about it. The way you can check points to make sure you're doing it right is just make up a bunch of ordered pairs where x equals 2 and then plot them, and then you'll see what kind of line you get. So if we make up a bunch of weird ones like 2, 0, how about 2, 4, how about 2, negative 1? Let's plot these and see what we get. So 2, 0, 2, 4, 2, negative 1. Do you see how these 3 dots make a vertical line? There you go. So that's what it means to be x equals 2. All your x's are 2, and the y can be whatever you want. So that's why it's vertical. Okay. Likewise, y equals a number. That's going to be the reverse of this. This is going to be a horizontal line for pretty much the same reasons. If we make up a bunch of random points where y equals negative 3, we'll pick 0, negative 3, 1, negative 3. How about negative 3, negative 3? And if we plot these, let's see, 0, -3, 1, -3, -3, -3. You see that they make a horizontal line. Okay. Now we actually need to make our line, but we can't just make them solid all the time. We have to think. Does that have a line under it? No, so we're going to make a dashed line. So this vertical one has to be dashed. All right. There is x is less than 2. This one doesn't have a line either, so this one is also going to be dashed. So our horizontal line is going to be like that, also dashed, because we don't have a line. This one will be solid because there is a line under there, but we have to figure out what this thing looks like first. So we pretend it's an equal sign. Y equals x plus 3. So this is our y-intercept. So we go 1, 2, 3. And then our slope, there's not a number here, so it's an invisible 1. So our slope is going to be 1. We're going to go up 1, right 1. So up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1, and so on. And it's solid because there's an equal sign under. So I'm going to just cheat and use a nice straight line tool. Let's get a little skinnier than that. Okay. And close enough. Okay. All right, so there's our 3 lines. Now we need to figure out where does the shading go, because there's a lot of things going on here. All right. So let me just clean this up a little bit. Let's get rid of some of this stuff so we can see what we're talking about. All right. So let's pick a nice, easy test point. Let's test the middle of this thing first. Let's just pick 0, 0. Never pick one on the line because you're going to get something kind of weird. You're going to get, if you pick it on the line and it's a solid line, it will always work. And if it's a dashed line, it will never work. Like, is 0 less than 0? No, they're equal. Of course it doesn't work. That's what's going to happen anywhere on the line. So let's pick 0, 0 because it's not on the line. And we're going to plug that into our 3 different inequalities. So if we plug in 0, 0 here. 0, 0. This is x. This is y. So x is 0 less than 2. Where do I put the y? Because there's not a y in here, you don't need to worry about it. It's not important. So 0 is less than 2. That's true. So our test point works for this inequality. What that means is we're going to shade on the side of this green line where our test point is. So it's going to be going this direction. Okay. So let's go ahead. I'm going to shade the whole thing just to really make a point here later. Okay, so it's got to be that way from the green line. Let's try out our red line here. Y is 0, so 0 is greater than -3. That's also true. So that means I'm shading from this red line the direction of that test point. So it's going to go this way. Okay. Now we'll plug in 0, 0 for this one. So 0 is less than or equal to 0 plus 3. So this is 0 is less than or equal to 3. That's true also. So I'm going to shade this direction from my blue line. Okay. So the solution to this system of inequalities is the place where all of these are overlapping. So I'm going to erase everywhere all 3 colors don't overlap. So I'm missing blue up here, so we'll get rid of all this stuff. Can't get rid of all that. Let's see, down here I'm missing red. Red goes up, so I got to erase this chunk here. And then over here we're missing green because green goes this way. So I got to erase all this stuff. Okay. So our solution is any point inside this triangle. It's this region right here. That's the solutions. Anywhere in here will work. Anyone on this solid line will work. but the ones on the dashed lines will not work. So on your homework, what they're going to do is they're going to say, like, here's section A, here's section B. We'll call the inside of that section C, D, E. And they're going to say, which section is shaded? You say C, because that's where all the shading overlaps. Simple enough? All right, let's do one more just for practice. I'm going to only shade probably the region where I think it should go. I might draw one arrow and just kind of figure it out, but the erasing might get a little cumbersome. So let's do one more just to make our moms happy, and then we'll get you out of here. So y is less than 0, or excuse me, less than 1. So let's see. This has to go through the y-axis. It's going to be horizontal line at 1. So here's 1. There's no line under that, so it's going to be dashed. All right, there's our first line. Now we have y is less than negative x plus 3. So I'm going to pretend this is y equals negative x plus 3. Our y-intercept is 3. 1, 2, 3. And my slope is negative 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. So we're going to have, I'm going to use my line tool here. We're going to have a dashed. Let's go make it dashed. There we go. A dashed line, just right about there, going through those points. Okay. And it's dashed because we're missing the solid line under there. All right. Now our last one, we have y, pretend it's an equals, 2x plus 3. Okay, so our y-intercept is 3 again, so it's going to go through that point. And this time our slope is 2. So we're going to go up 2 over 1. All right, rise over run. So 1, 2 over 1. Let's go the other way. 1, 2 over 1. 1, 2 over 1. That's probably good enough. Now we'll use our line tool. Make it green. Make it dashed because, again, no line under there. And it's going to go through those points. All right. So now we just have to figure out where is the shading going to be. So I'm going to pick, let's pick 0, 0 again. You can always pick 0, 0 as long as your lines don't touch 0, 0. If they go through that one, pick a different point. Otherwise, 0, 0 is really nice. You could also do like 1, 0 or not 1, 1 because the red one goes through there, but you get the idea. So we're going to plug in 0, 0 as our test point. So we have 0, here, let me use the right color. For this one, 0 is less than 1. That's true. So the red is going to shade towards 0, 0. It's going to shade that direction. Okay, so that means automatically it can't be that section, it can't be that section, or that one, or that one. It has to be below this red line. So it's either going to be over here, in between these two, or in this little pocket here. All right, let's plug in 0, 0 to this blue one. So we have 0 is less than negative 0 plus 3. Negative 0 is just 0. So 0 is less than 3. That's true. So our blue line is going to shade that direction. So it can't be this section because that's on the wrong side of the blue line. Last one's green, so it's either going to be over here above the green line or over here below the green line. So plug in 0. 0 is less than 2 times 0 plus 3. So 2 times 0 is 0. So 0 is less than 3. That's true. So it's going to be on this side of the green line. So we have to be under the blue, under the red, and under the green. Our solution area is this. This kind of weird rectangle here. And if this keeps going forever, this shaded region will just keep getting shaded in those two directions forever. Runs up against this red wall here, kind of flattens on the top, but it's this whole area down here. That's where our solutions are. All right, that's your notes. That's another speedy one, only 20 minutes. So Make sure if you have any questions, go let me know. I'd love to help. Otherwise, maybe watch your notes again if you have a question. That always helps me when I'm stuck. And I'll see you next time. Don't forget to like and subscribe.